Welcome to another episode of Terry's Notes, and today we are going to be looking at oxidation and reduction. Now, oxidation can be defined as the gain of oxygen by a substance or the loss of electrons, and reduction can be defined as the loss of oxygen by a substance or the gain of electrons. Now, some people use the term oil rig in order to help them remember how to explain what is oxidation and reduction. So oxidation is the loss of electrons and reduction is the gain of electrons. So that's how we have oil rig. And a reaction in which oxidation and reduction occurs at the same time is called a redox reaction, right? As in reduction and oxidation. Now, what you need to be able to do is to determine what is called the oxidation number. Oxidation number indicates the oxidation state of an element in its free state or in a compound. So there are some rules that you need to remember. The oxidation state of atoms of an element in its free state is 0. So sodium, the oxidation state of sodium is 0. In the case of chlorine, in chlorine gas, the oxidation number is 0. Next rule is the oxidation number of elements that exist as simple ions in ionic compounds is the same as the charge on the ion. So if we have something like sodium chloride, we know that in sodium chloride we have Na plus and Cl minus. The oxidation state of sodium is +1, which is simply the charge on the ion, and the oxidation number of chlorine is -1, which is just the charge on the ion as well. Another example is magnesium oxide. We know we have Mg2 plus ions present, and we also have O2 minus ions present. So the oxidation number of magnesium is +2 and the oxidation number of oxygen is -2. Another rule that we have is the sum of all the oxidation numbers of elements in a compound is 0. So if we have a compound like magnesium chloride, the oxidation number of magnesium is +2 and the oxidation number of chlorine is -1. So if we have, so it's +2 for magnesium and -1 for chlorine. So since we have 2 chlorine present, it'll be 2 multiplied by -1. So this will give us -2. So +2 plus -2 equals 0. So the sum of all the oxidation numbers of elements in a compound is 0. The next rule is that the sum of all the oxidation numbers of the elements in a radical is equal to the charge on the ion. So if we have something like MnO4 minus, which is a manganate ion, and we were asked to find the oxidation state or the oxidation number of manganese. We let the oxidation state be X, and oxygen. Now we know that oxygen is typically -2, so it's 4 multiplied by -2, and this will be equal to the charge on the radical here is -1. So all we need to do is to solve for X and we will get the oxidation state of manganese. So X minus 8 equals -1. So therefore X equals -1 plus 8. So X is equal to +7. So the oxidation state of manganese in this case is +7. Then we have substances that have variable oxidation states. So hydrogen is usually +1, except in hydrides where it is -1. So for example, sodium hydride, sodium is +1 and hydrogen in this case is -1, right? Typically hydrogen is +1. In the case of oxygen, it is usually -2, except in peroxides where it is -1. Right? Now let's do some examples, some typical examples that would come in an examination question. We want to determine the oxidation number of the element on the line. Okay, so we have the solutions across here. So the first example is K2Cr2O7, and we want to find the oxidation number of chromium. So we start off by writing out our equation. The overall charge is 0. So, and potassium is in group 1, so it is, the oxidation number is +1. So it'll be 2 multiplied by +1. We got this 2 from here. And we are letting the oxidation number of chromium be X. So it'll be 2 multiplied by X for the second term in this expression. And then we have a 7. The oxidation number of oxygen is -2. So it'll be 7 multiplied by -2. So this will give us 2 plus 2x minus 14 equals 0. And when we solve for x, we end up with x is equal to +6. So that is the oxidation number of chromium in this example. In this other example, we have KMnO4, and we want to find the oxidation number of manganese, or the Mn. Potassium is in group 1, so the oxidation number is +1, plus x, which is what we need to find. And we have 4 multiplied by the oxidation number of oxygen is -2, and that is equal to 0. So we solve for x, and we end up with x is equal to +7. Notice that we don't just write 7, we have to put plus in front of it. And the next example is the sulfate ion, SO42-. So we let the oxidation number of the sulfur be x. So x plus, we have 4 oxygen, so it's 4 by -2. Now this -2 is the oxidation number of oxygen, right? And we're going to put that equal to the overall charge of this ion is -2. So we have x plus, open brackets, 4 multiplied by -2 equals -2. And if we solve for x, we get +6. Our next example is the ClO3- ion, and we want to find for chlorine. In this case, we let the oxidation number of the chlorine be x, and we have 3 for the oxygen, but the oxidation state of oxygen is -2, so it's 3 multiplied by -2. That's how I got this. And the overall charge is -1, so we need to put our expression equaling -1. We solve for x, and we get +5. So the oxidation number of chlorine in this case is +5. The next example is the ammonium ion, and we want to find the oxidation number for nitrogen. So we let the oxidation number be x, so it'll be x plus, we have a 4 here, so it's 4 multiplied by, we know hydrogen is always +1 except in peroxides, so it'll be 4 multiplied by +1, and the overall charge of the ammonium ion is, all we're seeing here is a plus, so that is really +1. And when we solve for x, we end up with x equal -3. So the oxidation number of the nitrogen is -3. Now, this is where students get confused as well. When we look at oxidizing and reducing agents, now, when a substance is acting as an oxidizing agent, it is reduced in the process. This is very important. Now, the trick with this is not to learn both definitions. You learn one and you can remember the other one. So when a substance is acting as an oxidizing agent, we need to know that it is reduced in the process. When a substance is acting as a reducing agent, it is oxidized in the process, right? So don't get confused. So what we are saying is, if we have a substance A reacting with a substance B, and this substance is an oxidizing agent, the oxidizing agent will oxidize substance B, but in the process, this substance, which is substance A, will be reduced. Okay, do you get that? If A is an oxidizing agent and it reacts with substance B, it will oxidize substance B and substance A will be reduced in the process. Let's look at the reverse now. If substance P is reacting with substance Q and substance P is a reducing agent, the reducing agent will reduce substance Q, but in the process substance P will be oxidized. Alright, so don't get confused with the statements, just understand what is happening. Now you need to be able to give examples of oxidizing agents. So the first example is acidified potassium manganate 7. Sorry, this is a typo here. It should be 7. So we typically write it as KMNO4/H+, and it is an oxidizing agent. When it acts as an oxidizing agent, it changes from purple to colorless because oxidizing agents are reduced. Now you need to understand the explanation as well. The MnO4- ion changes from oxidation state +7 to Mn2+. So it goes from oxidation state +7 to +2. The +7 oxidation state is purple and the +2 oxidation state is colorless. So that is why we are getting a purple to colorless color change. Another example of an oxidizing agent is acidified potassium dichromate 6, which is written as K2Cr2O7/H+. Alright, when it acts as an oxidizing agent, we know that it will be reduced. In the process, it changes color from orange to green. And the explanation is the chromium or the chromate ion is changing from oxidation state +6 to +3. The +6 oxidation state is orange and the +3 oxidation state is green. Iron 3 salts can act as an oxidizing agent. When it acts as an oxidizing agent, it is reduced. It changes color from yellow to pale green, and what is happening is that the +3 oxidation state of the ion is changing to +2. +3 is where we have the yellow color and +2 is a greenish color. In the case of concentrated sulfuric acid, which can also act as an oxidizing agent, what happens is that we get a pungent gas being produced. In this case, sulfur dioxide is being produced when concentrated sulfuric acid behaves as an oxidizing agent. Another oxidizing agent is nitric acid, and the change is that a brown gas is produced. In this case, nitrogen dioxide is being produced, and oxygen gas and chlorine gas are also oxidizing agents. Now we need to be able to give examples of reducing agents. Potassium iodide is a reducing agent, and the color change is colorless to brown. And the explanation for this is that iodine is being produced. Alright. Iron 2 salts also acts as reducing agents, and they change from pale green to yellow, in which case we are moving from oxidation state +2 to +3. If the iron 2 salts are acting as a reducing agent, it will be oxidized. So that is why it is going from oxidation state +2 to +3. Hydrogen sulfide is also a reducing agent. In this case, a yellow precipitate is formed, which is sulfur. Concentrated hydrochloric acid is also a reducing agent. In this case, a yellow-green gas is evolved, which is chlorine gas. Other reducing agents are carbon monoxide gas, and hydrogen gas. Now there are substances that can behave as an oxidizing agent and a reducing agent. Two examples are sulfur dioxide and acidified hydrogen peroxide. So they can act as both an oxidizing and a reducing agent. Now how do we test for an oxidizing agent? If we want to test for an oxidizing agent, we can just add potassium iodide, in which case the color changes from colorless to brown because iodine is being produced. Or we can add an aqueous iron 2 salt, and the change in this case is a pale green to yellow. Or we can use hydrogen sulfide. So what you need to do, try to remember at least 2 of them and note the change that is taking place, because once we observe the change, then it gives us a positive indication that an oxidizing agent is present. If we want to test for a reducing agent, we can add potassium manganate 7, and the color change we get is purple to colorless. Or we can add acidified potassium dichromate 6, and the color change is orange to green. Or we can add an iron 3 salt, in which case the color changes from yellow to pale green. So you need to remember a few of these and note the color change. Alright, these are typical examination questions. So for each of the following equation, identify the substance that is being oxidized and give a reason for your answer. Now when you get a question like this, the first thing you need to do, the question is asking for which substance is being oxidized. Now if a substance is being oxidized, if I were to just draw a vertical line like this, we have oxidation number, and this is 0. If we have an increase in oxidation number, it is called oxidation. Alright, so the first thing you should look for is look for substances that have an increase in oxidation number. Now in this case, zinc, the oxidation number is 0, and look on the right hand side, the oxidation number has changed to +2. So the question is asking which substance is being oxidized. In this case, we can easily tell that zinc is the oxidation number is increasing from 0 to +2. So the answer is zinc. For the second one, if we look at the iron, the oxidation number is +2, and the oxidation number after is +3. If we are moving from +2 to +3, that is an increase in oxidation number. So therefore it is the Fe2+ that is being oxidized, right? Not the chlorine. Chlorine, the oxidation number is 0, and the chloride ion is -1. Therefore we have a decrease in oxidation number, which a decrease in oxidation number is really a reduction. Right? Now this one is a little trickier. Now let's start with the easy ones. Nitrogen is 0 because it exists in its standard state. In this case we have copper solid, so this is also 0. So if we look at the copper in this case here, we know that oxygen is -2, therefore the copper is +2. Now copper is going from +2 to 0, so therefore it's a decrease, so that is reduction, so it can't be the copper. In the case of nitrogen, the oxidation number of the nitrogen is -3, because we know that hydrogen is +1, so therefore in nitrogen must be +3, and nitrogen is going from -3 to 0. So on a number line or a vertical axis, if we have 0 line here and we have -3 and we are going to 0, we are increasing oxidation number. Therefore it is the ammonia that is being oxidized. Okay, in this next question you have to identify the oxidizing and reducing agents in the equation below. So since we have ions present, we know the oxidation number of iron here is +2. Iron is +3. Manganese is +2. I'm just looking at the charge on the iron here. It's nothing complicated. And in the case of the manganate ion, well, we did this in one of the previous examples. The manganese is +7. Alright, so which is the oxidizing agent? If something behaves as an oxidizing agent, it will be reduced. So therefore we should see a decrease in oxidation number. Now the manganese or the manganate ion is moving from +7 to +2. Therefore, it is decreasing oxidation number. Therefore, the manganate ion is being reduced. If it is being reduced, it is behaving as an oxidizing agent. I need you to understand this logic. Right? Manganese is moving from +7 to +2. Right? Therefore, it is being reduced. And if it is being reduced, it is behaving as an oxidizing agent. Right? In the case of the Fe2+, we are moving from +2 to +3. If we are moving from +2 to +3, it means that the Fe2+ is being oxidized. And if it is being oxidized, it is behaving as a reducing agent. Alright? So I just want you to understand the logic, how we came up with this.